In this video, I'm going to go through the review for our first quiz on the tools of coordinate geometry. Number 1. A line passes through the point -3, 5 with a slope of -4. Graph the line on the grid provided and state its equation in point-slope form. So I'll worry about that point slope in a second. I'm going to start by graphing it. So they want me to start at this point and apply a slope of -1/4. So remember that slope, graphically, we could think about as our change in y values or our change in x values, or rise over run. So how far you went up or down over how far you went right or left. Now, if my slope is negative, rather than telling me go up 1 over 4, I'm going to start by going down 1 unit and then count right 4. 1, 2, 3, 4. And I'm going to keep doing that. Down 1 over 4. 1, 2, 3, 4. And I'll get one more point. Down 1, 1, 2, 3, 4. Now I'm going to get some points over here in this direction too, just by applying the slope in the opposite direction. So rather than going down and right, I'm going to go up and left. So up 1 over 1, 2, 3, 4. And that looks like I have enough points there. So I'm going to take my straight edge, and I'm going to connect those points the best I can. Make sure you have arrows at the end of your line. And normally we would have a label, but we don't know the equation yet. So I'm going to think about what point-slope form looks like. Remember, the equation for point-slope form looks something like this. Y minus y1 equals m, my slope, times x minus x1. Where m just represents whatever the slope of your line is, and x1, y1 represents any point on your line. So they gave me a point to use here, -3, 5, so I'm going to label that one as my x1 and my y1, and they already gave me my slope there. So when I substitute into that equation, y minus my y1 value, which is 5, equals my slope, -1/4, times x, now here's where it gets a little tricky, minus my x1 value, which is -3. So this technically is a correct equation, but remember, when you're subtracting a negative, it's really like you're adding a positive. Keep, change, change. So I'm just going to write that as x plus 3 instead. So you don't need to solve for y here. This represents the equation in point-slope form. For number 2, write an equation for the line that passes through each of the following points with a specified slope. Write each equation in point-slope form. So one more time, that looks something like this. So all you need to do is identify a slope and a point, which they gave us here. So it's just a matter of plugging in. Y minus my y coordinate of the point equals my slope times x minus my x coordinate of the point. I'll do that again for B. Y minus my y coordinate of the point equals my slope times x minus, now instead of writing minus a -1, I'm just going to change this to +1 here. For C, I'm going to do the same thing, but notice both of my coordinates are negative. So when I write the equation, minus a -2 becomes +2, and minus a -7 becomes +7. For number 3, write the slope-intercept form of each line that has the specified slope and point it passes through. Like in lesson 4, example 1, so this is something we did in class. It's easier to write it in point-slope form and then rearrange it to get into y equals mx plus b. Remember, that's called slope-intercept form because it shows you the slope m and the y-intercept b. So I'm going to start by plugging into point-slope form here. Alright, that's y minus y1 equals m times x minus x1, and I'm going to try to isolate y here. The first thing I'm thinking to do is to distribute that 4 into my parentheses there with multiplication. 4 times x is 4x. 4 times a minus 5 is minus 20. And the only other thing I need to do on this side of the equation is subtract that 2 to get y by itself. So I get y equals 4x minus 22. So this is in slope-intercept form, and I could easily see my slope equals 4, even though we already knew that. But my y-intercept, the new piece of information, is just tagging along at the end there. That's -22. I'm going to do the same process for B. I'm going to write it in point-slope form first, and then I'm going to rearrange. 3 halves times x, I could just write as 3 halves x. Now, if you're not sure what 3 halves times 6 is, you could always type into your calculator. It's just 9. And if I add 5 to both sides, I get y equals 3 halves x plus 14. So again, I know my slope here is 3 halves, and my y-intercept as shown by slope-intercept form is going to be 14. So that's where this line is going to cross the y-axis. Number 4, which of the following is an equation for a line that is parallel to this given line and passes through the point -3, 7? Well, one thing you need to remember is that parallel lines have equal slopes. So if I want it to be parallel to this line right here, it needs to have the same slope. The problem is, this equation isn't in y equals mx plus b form yet. So I can't identify my m or my slope. So what I'm going to do to start is I'm going to rearrange this so it says y equals mx plus b. I'm going to start by subtracting 10x on both sides. So I have 2y equals, and I'm going to write my negative 10x in front because I know for slope-intercept form, I want my x term to come first. And if I have 2 times y on the left-hand side here, remember the inverse operation of multiplication is division, so I'm just going to divide everything by 2. So y equals negative 10 divided by 2 is -5, plus 15 over 2. You could simplify if you want, that's just 7.5, but I actually don't care about the y-intercept here. If I'm looking for a line parallel to this given line, I only care about the slope. So I know that definitely has to be my slope of the line, and if I'm trying to look at these equations in point-slope form, remember the number next to the x minus x1 should be the slope. So number 1 and 2 both have a slope of 10, so I'm between 3 and 4 now. So if I look back to the question, they wanted to go through the point -3, 7. So when I subtract my x-coordinate with that x minus x1, I know I'm going to be subtracting a -3. So when I write my equation, I should really see a positive there. So it looks like y minus my y-coordinate equals my slope times x minus my x-coordinate. But again, if I'm subtracting a -3, I know that should be a positive there. So that's why it's answer choice 4. For number 5, if a line is drawn through the point 4, 10 such that it is perpendicular to this given line, then which of the following would be its y-intercept? You've got a couple different ways to do this. Number 1 is that you can notice that perpendicular lines have negative reciprocal slopes. So what that means is that if you could see your slope, you've got to flip the fraction and change the sign. So if my original slope here is 1/3, the slope that would represent a line perpendicular to that is -3 over 1, or you could just write it as -3, because it's just dividing by 1. So you've got a couple of options here. The first thing that you could do is you could write the equation in point-slope form, right? Because I know one point that's definitely on it, and I know my slope. So I could do y minus 10 equals -3 times x minus 4. This is probably the easiest way to do it. And I'm going to distribute to get this into y equals mx plus b form. -3x plus 12. And if I add 10 on both sides, I get y equals -3x plus 22. So that number hanging out at the end there, that shows me where I'm crossing the y-axis. Alternatively, and I'll write a little side note over here, if I think about slope-intercept form, something like this, I already know what my slope is, right? That should be -3. And I can plug in an x value and a y value here because I know one point that's definitely on the line, 4, 10. I could plug in 10 for y, and I can plug in 4 for x. And then in this equation right here, the only unknown I have is b, which represents my y-intercept. So watch what happens. -3 times 4 is -12. And if I add that 12 to both sides, 10 plus 12 is 22, so I find my b value, or my y-intercept, is still 22. So either of those would be perfectly good strategies to find the y-intercept if I know the point that's on the line and the slope. Number 6. In the following diagram, triangle ABC is drawn. With those coordinates, determine the slope of AB in simplest form. Well, remember, if I'm finding the slope of any line segment, I could see how far I change in the y-axis and how far I change in the x, but I always like to pick points that are a little bit closer just so I don't have to reduce my slope later on. So if I start at A, it looks like the next good point on the line that passes through one of those corners of the boxes perfectly is right there at -2, -2. So if I count here, 1, 2, I went up 2, 1, 2, 3, 4, 5, and I went right 5. So the slope of segment AB is 2/5. Again, if you count all the way from A to B, you can get that same slope as well. You'll just have to reduce your fraction first. Draw the line that passes through C and is perpendicular to AB. So remember, to find the perpendicular slope, I need to flip the fraction and change the sign, because perpendicular lines have negative reciprocal slopes. And it wants it to pass through point C, which is that -6, 8 that they've already plotted for us. So I'm going to go up to C, and I'm just going to apply that slope by counting. I'm going to go down 5, because it's a negative slope, 1, 2, 3, 4, 5, over 2. Down 5, 1, 2, 3, 4, 5, over 2. And I'll do one more. Down 5, 1, 2, 3, 4, 5, 1, 2. And it says to draw the line, so I'm going to take my straight edge, connect it straight on through. Try to do that a little bit better. And I have arrows. And again, I don't know the equation yet, so I can't label this. But normally we would want to have a label here telling me what equation that line represents. So it says to write the equation in point slope form. Remember, point slope is just y minus y1 equals m times x minus x1. And the reason I wrote down C here is because I know C is definitely a point on the line. And I already know the slope. So I have my x1, y1, and I have my m value right there. So I have all the pieces I need to plug in. Y stays as y, minus my y coordinate equals my slope, -5/2, times x minus a -6, or just +6. So just as a side note, now that we have the label, I can go back into my picture, and now I can give it a label because I know what the equation of that line should be. Now if point D, this is for part C here, if point D lies in the intersection of AB with the line you drew in B, mark D and state its coordinates. Well, D is right there, and it looks like if I'm counting correctly, D is located at -2, -2. So it asks what kind of triangles are CBD and CAD. Well, I don't really know anything about the side lengths. All I knew is that I drew a perpendicular line. And remember that perpendicular lines form congruent right angles. So both of those should be congruent right angles over there. So I could say that they're both right triangles, because I know they have a right angle, because perpendicular lines form congruent right angles. So technically what I drew here, if you don't remember the vocab word for that, that's called the altitude of the triangle. It's just a line that goes from a vertex that's perpendicular or makes right angles with the opposite side there. Number 7. Given 4 points E, F, G, and H, is EF parallel to GH? Show how you determine your answer. Well, remember, parallel lines have equal slopes. So if I could show that their slopes are in fact equal, that would be enough for me to determine if they're parallel or not. So I'm going to start by finding the slope of EF, and I'm going to find the slope of GH. If you don't remember the slope formula, remember that's y2 minus y1 over x2 minus x1. The subtraction of my y's over the subtraction of my x's. So if I'm just looking at E and F, I could label one of my points as x1, y1, and my other as x2, y2. Doesn't matter which one you label as which, as long as you're consistent with the 1s for one point and the 2 subscripts for the other. So my second y value is 1, minus my first y value is 5, over my second x value is 7, minus my first x value is 2. 1 minus 5 is negative 4. 7 minus 2 is 5. I'm going to use that same logic for GH. Right? So I'm going to take my y values, subtract them. 5 minus negative 3 over negative 8 minus 2. So what I did there is I just labeled my other point in my head real quick as x1, y1, and x2, y2. Now, remember, if you're subtracting a negative, it's the same thing as adding a positive. Keep change. 5 plus 3 is 8. Negative 8 minus 2 is negative 10. Now, from the offset, it might not look like these slopes are the same. But remember, if one piece of the fraction is negative, the whole fraction is negative. So negative 4 divided by 5 is the same thing as negative 4/5. And if I reduce 8 over 10, notice that both of these are divisible by 2. Right? So if I divide them both by 2, I can get a 4 on the top and a 5 on the bottom. And again, remember, if one part of the fraction is negative, the whole thing is negative. So if I'm analyzing these slopes, and I'm trying to determine if EF is parallel to GH, I would say yes. My reason being is that parallel lines have equal slopes. And I just showed that here. For number 8, which of the following represents an equation of a line perpendicular to the line represented by this equation? Again, remember, perpendicular lines have negative reciprocal slopes. So the first thing I'm going to do is I'm just going to rearrange that equation they gave me to find the slope, right? Because if I can get into y equals mx plus b, it's easy to see the slope in front of the x value there. I'm going to start by moving the 8x over with subtraction. So that equation looks like 2y equals negative 8x plus 18. And then I'm going to divide out my coefficient of 2. So I get y equals negative 4x plus 9. So it's a little tricky to find the negative reciprocal of negative 4, right? That's my original slope of this line. So I'm going to write it as negative 4 divided by 1. Because if I could see it as a fraction, it's a little bit easier to find the perpendicular slope because I see a 1 in the denominator, so I know I could flip that. And if I'm finding the negative reciprocal, that just means to take the opposite sign. So if I had a negative fraction to start with, my slope should be positive. Again, it doesn't matter that just the top's negative. That means that the whole fraction's negative as well. So if I see a negative in my slope, my negative reciprocal should be positive. And the only line here with a positive 1/4 slope is 3. So it doesn't matter what the y-intercept is, right? If I draw some line, let's say right here, and I draw a line perpendicular to it so it forms right angles, I could slide that line up and down. Let me try this. And it's still perpendicular regardless of how far up it is or how far down it is. So the y-intercept actually doesn't affect whether it makes right angles or not. It's just the slope. For number 9, what is an equation of a line that is perpendicular to the line whose equation is 2y equals 3x minus 10 and passes through negative 6, 1? Again, I'm going to do the same thing. I'm just going to start by dividing out the 2 so I can see the slope easier. Okay, so the slope of my original line is 3/2, which means the slope of the line perpendicular should be negative 2/3. Again, remember, you could just flip the fraction and change the sign to find the perpendicular slope. So I'm going to rule out 3 and 4. And then if it tells me it's going through a point, it's easiest for me to just write my equation in point-slope form and try to rearrange from there. So I'm going to distribute the negative 2/3 in there. Right, so y minus 1 equals negative 2/3 x minus 4. Again, if you have trouble multiplying fractions, you could just type it into your calculator. And if I add 1 to both sides, I find that y equals negative 2/3 x minus 3. Negative 4 plus 1 is just a negative 3, so my answer choice is 2. Alternatively, you could have taken this point, once you narrowed it down, plugged in negative 6 for x, and plugged in 1 for y to see which equation was true when you plugged in that point. Number 10. Which of the following is the slope of the line that passes through these 2 points? Well, again, remember the slope formula is change in y divided by change in x. So if I substitute in there 10 minus 11 over 14 minus 5 is just negative 1 over 9, or negative 1/9. Number 11, which of the following would be parallel to a line whose equation is this? Again, parallel lines have equal slopes, so I'm just going to rearrange this algebraically so I can more easily see the slope. Again, remember I always write my x term in front just because I know y equals mx plus b normally has the x term in front. I'm going to divide everything by 3 to find that y equals negative 4x plus 2. So the only one that has a slope of negative 4 is that one right there. Again, remember parallel lines have equal slopes. Number 12, which of the following is true about a line parallel to the y-axis and passes through the point 5, 8? Well, let's sketch a picture here, right? Let's say I've got these set of axes. Here's the y-axis right here. So the y-axis is some vertical line, right? It goes up and down. But I also need my new line to pass through the point 1, 2, 3, 4, 5. Let's assume that's 5, 8 over there. So if it's parallel to a vertical line, that means the line should also be vertical. So remember the equation of a vertical line is x equals. So it can't be y equals for 3 and 4. And I know it's x equals 5 because if I pick any point on this line, like if I pick this point right down here, that's I moved right 5 and I didn't move up or down. I moved right 5 and maybe my y coordinate there is negative 2 or something. The idea is that for a vertical line, all of the x values are the same, so that's why the equation of this line is x equals 5. But you need to remember that for any line that's vertical, the slope is always undefined. And the reason that happens is because if we apply our slope formula, change in y over change in x, let's just I'll take these 2 points that I marked right there and there. If I find the slope between them, change in y over change in x, you should see an issue already happening. 8 divided by 0. Remember, you can't divide by 0 because there's no change in x here. The vertical line slope will always be undefined because you can't divide by 0. As opposed to a horizontal line that's in the form of y equals, that will always have a slope of 0. And those are just some facts you need to memorize from the last lesson we did yesterday. For number 13, in the graph shown, triangle ABC prime is the reflection of triangle ABC over a line. What type of line has triangle ABC been reflected in? Well, if I'm trying to visualize the symmetry here, if I draw a vertical line somewhere about here, it looks like it'd be a mirror image. I could fold my paper over that line and all of my points would land on top of its image. So I would say that's definitely some vertical line. So if I know it's a vertical line and I'm looking for the equation, it's x equals something. So I could just count to see how far I moved to the right. 1, 2, 3, 4. So x equals 4 is the equation of that line there. Number 14. Write the equation of a line that passes through the points 5, 7 and negative 3, 7. So try to visualize this. Your 2 points here are 1, 2, 3, 4, 5, and I'm going to just eyeball this and say that's 7. And 1, 2, 3, 7 right there. You should notice something about the y coordinates of these 2 points. For negative 3, 7 and 5, 7, the y coordinate of both these points is 7. So when I draw a line straight through those, I get a horizontal line at y equals 7, so I know that's the equation of my line. Alternatively, you could always, if you weren't sure what to do, find the slope between those 2 points. 7 minus 7 over negative 3 minus 5 equals 0 over negative 8. Remember, 0 divided by anything is just 0, so my slope is 0. And I'm going to plug into point slope form here just to see what happens. Now remember, for point slope form, you could use any point on the line, so it doesn't matter what point you use. I'm going to choose that second point over there. So y minus 7 equals m, my slope, times x minus a negative 3, or just x plus 3. Now notice something interesting happens here. 0 times anything is just 0. So I could rewrite that right-hand side as 0. And if this is my equation right here, I could simply add 7 to both sides to isolate y. So if you could visualize that it's a horizontal line, that's going to be a little bit easier. But the process for writing the equation of a line works for vertical lines or horizontal lines, so you could always plug into point-slope form, unless you have an undefined slope where you just need to remember that it's going to be a vertical line. Speaking of which, for number 15, write the equation of a line that passes through the points -1, -2, and -1, 8. So again, if I try to visualize this, if I go left 1 and down 2, there could be one of my points. And if I go left 1 and up 8, there could be another one of my points. So if I connect those, remember you only actually need 2 points on any line to draw the line. That's a vertical line that has an x value of -1. So the equation there is x equals -1. The problem is, if you try to use that same logic for the last one to find the slope and then analyze from there, something weird happens. -1 minus -1, 10 divided by 0. Right, you can't divide by 0, so the slope is undefined here. So I wouldn't be able to plug in a point slope form. So you simply need to analyze this and show that it's a vertical line instead. For number 16, write the equation of a line that is parallel to the line x equals -5 and passes through the point 2, -8. Well, x equals -5, that's a vertical line that goes left 5 and then draws a line straight up from there. So I'm just going to sketch this to give myself an idea of what's happening. Right, for coordinate geometry, it's always a good idea to give myself a sketch. Alright, so I'm going to go left 5, 1, 2, 3, 4, 5. And I'm using my ruler so it's as precise as possible so I can better visualize what's happening here. This is x equals -5. And it passes through the point 2, -8. So this is the point I want it to pass through over here, 2, -8. Remember, if I want it to be parallel, I want it to never intersect and I have to have the same slope. So a line parallel to a vertical line should be another vertical line. So a vertical line is of the form x equals, and all of my x values on this line are going to be 2. So the equation of that line is x equals 2. If I instead wanted a line that's perpendicular to that line, maybe I'd be thinking about some sort of horizontal line, but we'll get there in a minute. For the last one, number 17. If triangle XYZ is those coordinates there, determine if it's a right triangle. Well, the first thing you should do is just plot your points to give yourself an idea of what this triangle looks like, because we should recognize that for any right triangle, we should be able to prove that there is one right angle, and that would be enough to prove that it's a right triangle. So if I sketch this picture right here, again, make sure you're using your straight edge so that your points and your sides for the triangle are as precise as possible. Okay, there's my triangle. If I want to determine if it's a right triangle, here's the process. Right triangles have one right angle. And remember that perpendicular lines form right angles. So my strategy here is to show that two sides are perpendicular to justify why there's a right angle somewhere. So to show perpendicular sides, I'm going to find three slopes. I'm going to find the slope between x and y, between x and z, and between y and z, and then from there I'm going to analyze. So I'm going to do this real quick. We've done slopes already a little bit. Remember, y2 minus y1 over x2 minus x1. For x and y, -2 minus 4 over -1 plus 1 is -6 over 0. Uh-oh, can't divide by 0. That's going to be undefined. So that just means that side xy is perfectly vertical, and that's okay. I could see that in the picture pretty well. For xz, change in y, those both have a y value of 4, right, if I'm looking for z and x there, divided by 7 plus 1 equals 0 over 8. Remember, 0 divided by anything is 0. And I'm just going to find the slope of yz2, even though it doesn't look like there's a right angle there, just to have my work organized. 4 minus a negative 2, or just plus 2, over 7 minus negative 1, 6 over 8, or if I divide those both by 2, I get 3 over 4. So here's what you should notice here. We're looking for perpendicular lines. Remember, perpendicular lines have negative reciprocal slopes. So like if I saw a slope like 1/2 and negative 2 over 1, I would be able to show the two lines are perpendicular. I don't see any of that here, but I do notice something about xy and xz. So this is a vertical line right here because it has a slope that's undefined. This is horizontal right here because it has a slope of 0. And remember that a vertical line is always perpendicular. That's what that symbol means, like an upside down T. A vertical line is perpendicular to a horizontal line, which would mean that there's a right angle right at x and that this is a right triangle. So what this work showed is that I have a right triangle. So I'm just going to explain my work a little bit here. Since xy is perpendicular to xz, angle x is a right angle. Therefore, that's what that 3 dots means. That just means, therefore, triangle XYZ is a right triangle. Right, because we were able to show that we have one right angle at x because I have two perpendicular sides as justified by my slope. Therefore, the triangle I have is in fact a right triangle.